Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSE. So in this video, I'm going to discuss about the bisection method. So it is the one of the simplest and most reliable iterative method for solving nonlinear equations, and it should be also called as binary chopping or half interval method. So based on the repeated application of intermediate value theorem. So this bisection method is one of the simplest and most reliable iterative method for the solutions of nonlinear equations. So the other synonym for bisection method is the binary chopping method, or can able to call it as half interval method. So based on the repeated application of this intermediate value theorem. So bisection method is given an initial interval as a comma b, so which is going to contain the root, and this bisection method will cut this interval into two halves, and you have to check whether which half contains the roots of the equation. So this bisection method will also cut the interval halves until the resulting interval is extremely small. Okay, so the root is approximately equal to any value in the final interval, right? So this bisection method will cut the interval into two halves until the resulting interval is extremely small. The roots is approximately equal to any value in the final interval. So the bisection method is going to be given an initial interval like this, which contains the root, and this bisection method will cut the interval into two halves and check whether the two halves interval contain the roots of the equation. So this bisection method will cut the interval into halves until this resulting interval is extremely small. So here the root should be approximately equal to any value in the final interval. So this should be the graphical representation of this bisection method. Suppose I am going to have the interval like this. So how can I able to represent in the graph? So this is the interval, and the graph should be looks like this. So f of a value is this one, and f of b value is this one, and this is the curve what we obtain, that should be the f of its value. So when we are going to cut this interval into two middle, so the midpoint middle value should be obtained as a plus b by 2. So from the previous graph, so if I'm going to have the interval like this, so this is f of a value and this should be f of b value. So the middle of the curve should be obtained as a plus b by 2, that should be this one, and by intersecting the curve like this, and midpoint should be treated is equal to a plus b by 2. Because the sign of f of m is equal to the sign of f of a, when able to proceed the search in the new interval as a comma b. So the sign function of f of m is not equal to sign of f of a, so we have to be proceed the search in the new interval of a comma b only. So let's take x1 is equal to a and x2 is equal to b. So let us define another point x0 be the midpoint a and b, then x0 should be write it as x1 plus x2 by 2. Okay, so x1 is equal to a and x2 is equal to a I'm taking, and then we have to define another point x0 to be the midpoint between a and b. So that should be written as x1 plus x2 by 2. If f of x0 equal to 0, then we have the root at x0, and f of x0 and f of x1 should be less than 0, then the root should be between x0 and x1. And if f of x0 and f of x1 less than 0, then there is the root between x0 and x2. So let x1 is equal to a and x2 is equal to b. So let us define another point x0 to be midpoint between a and b. Okay, so then x0 is equal to x1 plus x2 by 2. Now we are going to have the three conditions. If f of x0 equal to 0, then we have the root at x0. If f of x naught and f of x1 should be less than 0, then the root is in between x naught and x1. If the f of x naught and x2, there is another root that should be x naught, f of x naught and x of x2 is less than 0, then the root is in between x naught and x2. Let us take an example. So we're going to have a simple function to illustrate the execution of bisection method. Suppose if I'm going to have the function like this, so x cube minus 5x plus 1. Suppose if I'm going to start an interval 0 and 1, so f of 0 equal to, so 0 cube minus 5 into 0, that should be f of 0 should be 1. Similarly, if I'm going to substitute 1 in the equation, so then this is the value I'm going to get. So the interval is going to contain the root because the sign of f of naught is not equal to the sign of f of 1. So here the sign is plus and here the sign is minus. So normally the interval should be lies between 0 and 1, but here the sign is different. So what I'm going to say, so in iteration 1, so let us take x1 equal to 0 and x2 equal to 1 and substitute those, calculate this x naught value, so 0 plus 1 by 2, so that should be 0.5. So f of 0.5 should be, so minus 1.375. So that means f of x1 and f of x naught is less than 0. So the root is lies in between 0 and 0.5. Clear? So if I am going to have x1 equal to 0 and x2 equal to 1, so then x naught is equal to x1 plus x2 by 2. So x naught is equal to x1 plus x2 by 2. Then x1 plus x2 by 2 means, so I can able to get 0.5. So therefore 0.5 should be, by substituting this 0.5 in this equation, so I can able to get minus 1.375. So f of x is equal to x cube minus 5x plus 1. So f of x is equal to x cube minus 5x plus 1. So if I'm going to write, substitute this in this one, so I'm going to get minus 1.375. So this is the value. That means f of x naught value. So what about x1? So f of x1 plus f of x naught is less than 0. So the root is going to be lies in between 0 and then 0.5. So in iteration 2, I'm going to consider another thing. So x1 equal to 0 and x2 is 0.5. So then x naught is equal to x1 plus x2 by 2. So that means 0 plus 0.5 by 2, that should be 0.25. Okay. So let x1 is equal to 0 and x2 equal to 0. Okay. Then x naught is equal to x1 plus x2 by 2. That should be equal to 0 plus 0.5 by 2. That should be 0.25. So f of 0.25 is equal to, so by substituting this, so f of x is equal to x cube minus 5x plus 1. So 0.25 whole cube minus 5 into 0.25. So then I can able to get, so minus 0.234375. So this is the value. So that means f of x1 and then f of x naught is less than 0. That means the root is going to lie in between 0, 0.25. Okay, that is the answer. So in iteration 2, so if I am going to have x1 is equal to 0 and x2 is equal to 0, so I am going to calculate the x naught, that should be x1 plus x2 by 2. So after substituting this, I am going to get this value. So what should be the value of f of x naught? So by substituting this in this equation, so in this equation, so I'm going to get this value. That means f of x1 and f of x naught is less than 0 only. That should be 0 and 0.25. So the root should be lies in between 0 and 0.25 only. So by constructing this, I'm going to take one table like this. So x1, x2, x0. Okay. So I'm going to construct this. So in iteration 1, I'm going to calculate x1 0 and x2 should be 1. So x0 is 0.25. And similarly, if I'm going to take x0 is 0 and x2 is 0.25, so then I'm getting x0 is equal to 0.25. Similarly, on repeating this process, so x1 is 0 and x2 is equal to 0.25, then I'm getting the x0 value is 0.125. Similarly, if I'm going to get so x1 as 0.125 and x2 as 0.25, I'm getting this value. Similarly, if I'm going to consider x1 is this one and x2 as 0.25, I'm getting this value. Based on this value, therefore x0 should be less than, so and this should be the greater than, this two is greater than, and here also it should be less than. So since it is greater than, I'm taking the x1 value should be here. Since it is greater than, it should be here. If it is less than, the x1 value should be 0. So after calculating all these values, so where is the root now? So the root is going to be lies, so in between 0.1875 and 0.2875. Okay, so this is the root that should be lies in between 0.875 and 0.21875. So this is the approximate root that should be taken as the midpoint of the interval. So when it comes to advantages of this bisection method, so it should be simple and easy to implement, and one function evaluation per iteration, and the size of interval which is going to contain that should be reduced on each iteration, and no less knowledge of derivative is needed. So that is the advantages of this bisection method. So this bisection method is simple and easy to implement, and one function evaluation per iteration is needed, and the size of interval containing 0 is reduced after each iteration, and no knowledge of derivative is needed. And disadvantage is that so it is slow to converge and good intermediate approximation that may be discovered. So the disadvantage is that so you have to be slow to converge and you have to be good intermediate approximation may be discovered. So one function per evaluation is iteration, and size of interval containing the 0 is reduced after each iteration, and no knowledge of derivative is needed. So the disadvantage is that so it is very slow to converge and the good intermediate approximation may be discovered. And these are some of the references. So when it comes to this bisection method, so this is one of the simple and most reliable and iterative method for solution of nonlinear equations. And this method is also known as binary chopping and half interval method, and based on repeated application of intermediate value theorem. And here in this bisection method is going to give an interval, so that should be containing the root. And normally this method is going to cut this interval into two halves, whether the two halves contain the roots of the function or not. And this bisection method will also cut the interval into two halves until the resulting interval is extremely small. Suppose if I am going to have an interval like AB, so this is the interval of A comma B, and in between, so I'm going to have f of A and f of B. So it is going to cut this interval, and if I'm going to consider the midpoint of that, then I can able to this should be the middle value of this curve. Okay. So, but here I'm going to consider the sign also. So whether it should be positive or negative sign, that should be also one of the consideration here. Suppose if I'm going to have the example like x1 is equal to a and x2 is equal to b, then I have to calculate the x0. So x0 should be calculated as x1 plus x2 by 2. So if I'm going to have f of x0 equal to 0, then that the root should be at x0. Whenever this f of x0 and f of x1 should be less than 0, then the root is in between x0 and x1. And f of x0 and f of x2 should be less than 0, then the root is in between x0 plus x2. So example, so we are going to have a simple function like this, f of x is equal to x squared minus 5x plus 1. So here I'm going to write 0 and 1 interval. So after substituting this 0 and 1 in this equation, I'm going to get this one. But here the signs are different. So the sign of f of x is plus 1 and should not be equal to minus 3. And I'm going to consider it, right? So we're going to see the example. So x0 is 1, 0 and x2 is 1. So after I'm calculating x0. So after calculating this x0, I'm going to get 0.5. So after substituting this value in the corresponding equate function, so I'm going to get this value. So that means the f of x1 and f of x1 should be less than 0. So that means the root is going to lie in between 0 and 0.5. Similarly, I'm doing another iteration. So x1 should be 0 and x2 should be 0.5. So after calculating this x0, that I'm getting 0.25. So this one is going to be substituted in the function. I'm going to get this value. That means the value is going to be lies in between f of x1 and f of x1. That means 0, 0.25. This sequence of interval should be as follows. So x1 equal to 0 and x2 is equal to 1, that should be 0.5. If x1 equal to 0 and x2 is 0.5, that should be 0.25. And x1 equal to 0 and x2 is equal to 0.25, that should be 0.125. Okay. So after seeing this, so the root is going to be lies in between 0.1875 and to 1875. So the advantages is that so it is simple and easy to implement, and one function evaluation per iteration and size of interval containing 0 iterators of each iteration, and no knowledge of derivatives needed. And disadvantages slow to converge and good internet approximation is important. And these are the differences. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.